Good morning, everybody. I'm Luca Marconi, and today I'm going to present your white paper towards Explainable Artificial Intelligence for Personalized Teaching, results and experimental activities on the WhoTeach educational platform. In the paper, we basically provide the first stages of our ongoing research project to empower the recommender system of the present platform, WhoTeach, by the means of explainability, in order to empower and to reinforce the way it provides recommendations for teachers or experts to create customized learning and training paths. We also report the results on the first experimentation of the present platform to a selected set of users, and a model based on graph attentional mechanisms to start to include explainability in the system. The presentation flow starts from a general introduction related to the context and the problems of the research area, and then I'm going to show you the research activities in our case study, which is the platform WhoTeach. Artificial intelligence is particularly needed in education in order to manage learning and training processes, especially when it comes to explainability. It is specifically needed for reinforces the recommendations output the decision provided by the models with a higher degree of interpretability and then transparency. Specifically, in the case of educational platform, there is the need for artificial intelligence and also for collaborative features. And then explainable artificial intelligence can be a key for empowering the way decision support systems in general, learning management systems, and recommended system, reinforced recommended and social features can help and support education. In previous works, we have studied that in literature it is shown that there is a higher level of personalization when it comes to social explainable recommended system, which is particularly challenging for applying these kind of techniques in education. The research goals of our study then was to reinforce the social engine and the recommended system of the platform WhoTeach by the means of explainable approach, for increasing the ability of the platform to create and manage customized learning and training paths and courses. Our case study is the platform WhoTeach, which is a social intelligent learning management system developed by Social Tingham, and it is aimed at promoting the development of customized learning and training path thanks to the synergy between its different components, able to manage educational ecosystems, both from an asynchronous and synchronous point of view. In particular, there's a learning management system, a recommender system, and social and interactive features. The evaluation of the recommender system was conducted by the means of cooperative evaluation approaches, and it was aimed at effectively analyzing the way the recommender system provides recommendations to the users. It was conducted by the means of different experiments, and different tasks were proposed to users. Specifically, when it comes to the results provided, the results show that the personal recommended system, while it is already quite satisfying for users in general in the way it provides resources, it provided resources to users, and there is a need for explainability, for empowering explainability in the system, in order to lead a further step in its evolution and empower the way the platform supports education. So we have decided to use graphs to model the relationship between users and resources, and we have studied and we have considered attentional neural mechanisms based on feed-forward neural network on the top of a graph attentional layer, and in particular the user and item matrix has been provided by the system, and the aim is to optimize the system by the stochastic gradient descent approach. And specifically, we have created an information representation allowing us to visualize either the users or the resource as a main element according to the neighborhood, and provide attention weights. Attention weights are given to the most relevant information encoded in the embedded representation for the users or resources. And the attention weight can stimulate explainability. We can start to understand explainability in the system thanks to the possibility to explain why a given resource is recommended to a specific user. These have also been studied in other cases, in other systems or domains. We have also compared our model to other alternative models, and we have obtained we have simulated the results in numerical experiments, which basically confirm the expected levels of performance. So the attention model is useful for allowing us to understand the structure of the user preferences, and then to improve the recommendations provided. And following that, we are going to understand the future steps. Thank you very much.